Hello, today we are going to learn the algebra of functions. So let's look at the definition first. The algebra of functions: sum, difference, product, and quotient of functions. So let's consider two functions f and g. The sum f plus g of x equals f of x plus g of x. The difference f minus g of x is f of x minus g of x. And the product f times g of x equals f of x times g of x. The quotient f divided by g of x equals f of x divided by g of x, provided g of x is not equal to 0. So since it is a quotient, if g of x equal to 0, the function becomes undefined. So let's look at some examples. So let's consider the function f of x equals square root of x plus 2. Then consider another function, g of x equals square root of 2 minus x. So we have given two functions. We need to find the algebra of functions. So algebra of functions, that is, we have to find f plus g of x, that equals f of x plus g of x. So square root of x plus 2 plus square root of 2 minus x. So you know that these are radical functions. We can add or subtract only like radicals. Like radicals are radicals with the same radicand and the same index. Here you can see that these two functions have the same index, but the radicand, here it is x plus 2, here it is 2 minus x. So they are not like. So we can keep the answer like this. Then let's find f minus g of x. So that is f of x minus g of x. So square root of x plus 2 minus square root of 2 minus x. And let's find the domain of these functions. So when you consider f plus g of x, so we have square root of x plus 2 plus square root of 2 minus x. So to find the domain of this combination, first we have to find the domain of each of these radical functions. So the domain of the first function, to find the domain of the radical function, the rule is that the radicand, that is x plus 2, must be greater than or equal to 0. So when we solve this inequality, we have to subtract 2 from each side. So x greater than or equal to negative 2. So when you consider the next function, square root of 2 minus x, so again, the rule is the radicand should be greater than or equal to 0. So 2 must be greater than or equal to x, or we can also write this as x less than or equal to 2. So we need to find the domain that is common to both of these functions. That is the domain of this combination, or in other words, the algebra of this function. So when you graph these solutions on the number line, if you plot this point as -2 and this point as 2, for the first function, the domain must be greater than or equal to -2. So it includes 2. So we usually use bracket and all points to the right of -2, right? So it is like -2 to infinity, or this in interval notation, bracket -2 to infinity. Okay, so let me correct this one. So it is -2 to infinity. And the next solution is set is x less than or equal to 2. So it includes 2, all points less than or equal to 2. That is to the left of 2. That is like -infinity to 2 with a bracket, right? So from this number line, you can see that this is the domain, or this is the common portion. This is the domain common to both the functions, or in other words, this is the intersection of the domain of the first function and the second function. So the domain of this function is bracket -2 to 2. So we have already found what is f minus g of x. So the domain of that function is also the same. You can see that these are the two functions. We already found the domain of both the functions and also the domain common to both. So the domain of f minus g of x is also -2 to 2. Okay. Let's look at the next algebra of function, that is like f times g of x, right? That is f of x times g of x. So you remember the function. The first function is square root of x plus 2. The second function is square root of 2 minus x. So we can multiply these two functions together because they have the same index. That is, index is 2. You know that's for the square root. We don't usually need to write 2 as the index. So x plus 2 times 2 minus x. We can keep these two functions under the same radical sign. So you will get, we can distribute x times 2 is 2x, then x times -x is minus x square, then 2 times 2 is 4, and 2 times -x is -2x. So when we rearrange the terms, we'll get -x square plus 4. So when you look at this function also, you can see that we use the same function. We'll again end up with a function like this, right? So the domain of this function is also bracket -2 to 2. Okay. Then let's consider the last one, f over g of x. So square root of x plus 2, that is f of x, divided by g of x, that is square root of 2 minus x. So when we consider the domain of each of these functions, you can certainly keep this function under the same radical, or you can just write the function separately, it's fine. So to find the domain of this function, we have to domain the function of the domain of each of the functions separately. So we can see that the domain of the first function, we have already seen that it is x greater than or equal to -2. And when you consider this, the second function, so 2 minus x less than or equal to 0 or x less than or equal to 2. So the domain common to both functions is bracket -2 to 2. But when you consider 2, the same domain, can we have 2 as the value of x? Look at the denominator. So if x equals 2, then 2 minus 2 equals 0. So the denominator becomes 0. So division by 0 is undefined. So we need to exclude 2 from the domain of the functions f and g, right? So we need to exclude. We cannot have 2 in the domain of this function because that 2 makes the denominator 0. So the domain common to both functions and the domain of f over g of x is bracket -2 to 2 with a parenthesis. That's the main difference between the domains of the functions we have already seen and the last function f over g of x. Thank you.